Welcome back to another Explainer. Today, we're tackling something that is honestly profoundly human, and at the same time, deeply scientific. We're looking at the aftermath of a traumatic brain injury, or TBI. It's a heavy, life-altering event, right? It impacts millions of people every single year, often leaving patients and their families feeling just completely helpless. But today, we aren't just dwelling on the injury itself. Instead, we're going to focus on the incredibly inspiring science of brain recovery. So let's jump right in.
Here's our roadmap for this explainer. We'll start with the brain's hidden resilience, then look at its biological repair kit and how exercise acts as a catalyst. After that, we'll get into rewiring the body and mind, engaging senses and emotions, and finally, looking at the road ahead. We'll be traveling all the way from microscopic biomarkers right down to practical physical therapy exercises.
Okay, Section 1, the brain's hidden resilience. We really have to start by acknowledging the very real fear and uncertainty that follows a brain injury. It's a time when the future feels, well, incredibly clouded.
And that leads us to the ultimate critical question. When you or a loved one suffers a severe blow to the head, this is the absolute deepest anxiety. Can the brain truly relearn lost skills after a devastating injury? It's a terrifying thing to wonder about. But the scientifically grounded message, the answer we're getting from top researchers and therapists, is a resounding yes, absolutely. And that brings us to exactly how it pulls this off.
And the magic word here is neuroplasticity. Basically, it's the brain's ability to adapt and reorganize itself. Think of your brain like this massive, bustling city network. If a major bridge is completely taken out in an earthquake, traffic just stops, right? Well, neuroplasticity is the city's amazing ability to instantly start rerouting that traffic, literally paving entirely new side streets and turning them into superhighways. It allows the healthy regions of the brain to step up and actually take over those damaged functions. It's literally a biological marvel.
Moving on to Section 2, the biological repair kit. Let's zoom in a bit to the microscopic level to see exactly how the brain facilitates this massive rerouting process.
Say hello to BDNF, or brain-derived neurotrophic factor. If neuroplasticity is the act of rerouting the city traffic, BDNF, well, that's your brain's biological construction crew. It's this absolutely crucial neurotrophin that acts almost like Miracle-Gro for the brain. It promotes neuronal survival, plasticity, and memory formation. Without it, those new roads, they're just not getting rebuilt.
Now, what's truly fascinating is the stark contrast in the data we're looking at here. This box plot, which comes straight from a perspective study in the Journal of Neurosciences in Rural Practice, shows a really dramatic difference. Check out the green box on the right. Those are our healthy controls, sitting pretty at a comfortable BDNF level of around 323 nanograms per milliliter. But then look at the red box right in the middle, which represents severe TBI patients on the very day of their injury. Their BDNF is just completely depleted, down to around 38.5. Their construction crews are basically totally missing, exactly when they are needed the absolute most.
And this visual perfectly captures why those starting BDNF levels are such a big deal. When looking at patients 1 month out from their injury, the ones who eventually had good outcomes, that tall blue bar you're seeing, well, they started on day 0 with a median BDNF level of about 180. The patients with poor outcomes, the tiny orange bar, started with a level of just 16. Let that sink in. The patients who recovered well started off with a biological repair kit that was literally over 10 times larger.
All right, Section 3, exercise as the catalyst. So the science is clear on the biology, but how do we actively influence it?
A recent systematic review of clinical trials hit the nail right on the head, stating submaximal aerobic exercise can alleviate brain injury-related symptom burden. We usually think of aerobic exercise as just being for heart health or, burning calories. But in the context of a brain injury, it's a real game changer. It is a direct, active catalyst for neural recovery. When you exercise, you are actively signaling your brain to pump out more of that BDNF we were just talking about.
And the evidence backs this up across the board. In animal models, we're seeing deep cellular proof. Exercise literally increases the number of newborn neurons in the hippocampus, and it promotes synaptogenesis, which is just a fancy way of saying the forming of new synapses. But we're not just seeing this in mice. In human trials, we are now actively verifying these exact benefits through advanced neuroimaging. Functional and diffusion-based MRI scans are showing actual structural brain improvements in TBI patients who engage in regular exercise.
Which brings us to Section 4, rewiring body and mind. Now that we understand the big picture clinical evidence, let's look at some of the practical exercises designed by Flint Rehab.
First up, we've got movement and motor skills. The goal here isn't to suddenly become an Olympic athlete, it's to force the brain to quickly process movement and rebuild those motor pathways. Really simple actions like heel-to-toe walking or just standing on one leg heavily engage your balance centers. Fine motor skills, like tapping each finger to your thumb in succession, that requires a massive amount of neural coordination. By doing these things repetitively, you are manually laying down the asphalt for those new neural pathways.
Next, we jump into the cognitive bucket. A brain injury can really take a toll on memory and executive function, but you can stimulate cognitive flexibility by taking large chunks of information and, well, chunking them into smaller sets, kind of like how we naturally remember phone numbers. Or you can set up real-life decision-making scenarios, like planning out a grocery list from scratch. These aren't just silly games. They are literal, targeted resistance training for your memory and problem-solving networks.
Speech and language can also be profoundly impacted. Alongside things like reading aloud and making exaggerated lip movements, there is this truly fascinating technique called singing therapy. Now, what's so cool about this is that singing utilizes melody and rhythm, and that actually bypasses damaged speech pathways entirely because it uses a completely different area of the brain. Seriously, people who literally cannot speak a single sentence due to an injury can often sing that exact same sentence flawlessly. It is just a stunning example of neuroplasticity in action. Moving into Section 5, engaging senses and emotions. We definitely cannot ignore the sensory and emotional elements of neurorehabilitation.
Sensory stimulation is really all about waking the brain up from different angles. Notice the stark contrast between these two sensory exercises. Visual tracking, like following a moving pen with your eyes without moving your head, targets spatial awareness and visual focus. But on the totally opposite side of the spectrum, you have aromatherapy. Smelling a strong, distinct scent like lavender and actively trying to identify it forces the brain to rewire its olfactory memory. By targeting entirely different sensory inputs, you're activating wildly diverse neural networks. But here's the thing, none of this works if the patient is totally overwhelmed by stress. Emotional regulation is just as absolutely crucial as the physical therapy. You have to build mental resilience. Step 1 is progressive muscle relaxation, literally physically letting go of tension. Step 2 is deep diaphragmatic breathing, which actually pushes more oxygen directly into the healing brain. And step 3 is task breaking. Don't look at the whole giant mountain you have to climb. Just focus on the very next achievable step. This stops the brain from just shutting down due to pure overwhelm.
And finally, Section 6, the road ahead. Let's summarize this journey we've taken today, from the initial cellular damage all the way to proactive, holistic healing.
So the main takeaway is this. The recovery process we've outlined today doesn't just happen by accident. Harnessing neuroplasticity requires really consistent, repetitive practice. It's all about applying the biological principles of BDNF, utilizing that amazing catalyst of aerobic exercise, and dedicating yourself to those structured physical, cognitive, and sensory drills day in and day out. Patience isn't just a virtue in this scenario, it's quite literally a medical requirement.
Which leaves us with this final, awe-inspiring thought to ponder. If our biological hardware, our very brain structure, can constantly rewire, remodel, and find entirely new pathways around catastrophic damage, well, what are the true limits of human resilience? Recovering from a traumatic brain injury is undeniably a massive, daunting challenge, but it's also the ultimate testament to the brain's incredible, unstoppable adaptability. Thank you so much for joining me on this explainer. Keep learning, stay curious, and I'll catch you in the next one.